So let's take a look at number 1. So first, let's find the domain. Remember, our domain are the x values. So it's always smallest to largest. So we want to go from left to right. So what x value does my graph start at? -7. Bracket or parentheses? So bracket -7. And then if we put our pencil over our graph going from left to right, we're touching graph all the way until we get to what number? 9. Awesome. Bracket or parentheses? Parentheses, because it's an open circle. Now our range, we start at the bottom. So what number does our graph start at for the y values? -3. Perfect. Bracket or parentheses? Bracket, -3. And then where does our graph stop? 7. Bracket or parentheses? Parentheses, because it's an open circle there. So it's always smallest to largest values for domain. You go from left to right. Range, you go from bottom to top. Now let's figure out where we're increasing, decreasing, and constant. Remember, these are always x values and always parentheses. So starting at the left side of our graph, we're walking downhill. So we're decreasing from what x value to what x value? -7 to -4. Perfect. Then we start walking uphill from here to here. So from what x value to what x value? -4 to -2. We are increasing. Then we start walking in a straight line. So we are constant from here to here. So from what x value to what x value? -2 to 3. Perfect. So we're constant. -2 to 3. Then we start walking downhill again. So we're decreasing from here to here. So from 3 to 6. Perfect. So I'd put a union because we've got 2 parts where we're decreasing. So from 3 to 6. And then we start walking uphill again from here to here. So we're increasing from where to where? From 6 to 9. So super important with increasing, decreasing, and constant. It is always parentheses, and you're always talking about the x values. All right, so with number 4, first we want to find f of 0. So I go to where x is 0, because this is talking about our x value. I'm going to go to wherever my graph is. What's our y value there? -2. So f of 0 would be -2. Then let's find f of 5. So we're going to go to our graph, go to where 5 is. It would be -2, yeah.
How do you know that you have to go down -2?
So you just go to where your graph is. So like if it said f of -1, we'd go to -1 on the x, and we jump to wherever the graph is, which would be down here. So then it would equal the y value of -1. So this is our x, and that's our y. If it said f of, let's say, f of -4, I'd go to -4, 1, 2, 3, 4, jump to where my graph is. What's our y value? 5. Perfect. So that's our x, and that's our y. All right, let's look at number 2. So first, let's start with our domain. George, what do you think the domain is?
-infinity.
Perfect. Our arrow is pointing to the left forever and to the right forever, so it'd be -infinity to +infinity. What about our range?
-infinity.
Same thing. Our arrows are pointing down forever and up forever, so -infinity to +infinity. Now for increasing, decreasing, and constant. Again, these are always what? X values and parentheses. So starting at the left side of our graph, we are walking downhill, so we're decreasing.
Negative infinity to -3.
Awesome. So since our arrow is pointing to the left forever, we're decreasing from negative infinity to the x value of -3. So negative infinity to -3. Then from here, we start walking uphill. So from the x value of -3 to where? To +3. So we're increasing from -3 to +3. Then we start walking downhill again. So we're decreasing from 3 to infinity because it's pointing to the right forever. So remember, we're talking about x values. So we are decreasing again from 3 to +infinity. So we'll find the domain and range here. So domain, we do the x value. So we start at the left side of our graph. So if we hover our pencil over the left, we would have what to what for our domain? Negative infinity, but then it stops at -3. Because it's an open circle, it'd be a parentheses. Our graph starts again at what x value?
-2.
-2 to what?
Does it stop or just keeps going?
To 1, because it stops, it goes from here to here, so from here to here. So bracket, because they're closed circles, from -2 to 1. And then it has a gap in the graph, and then it starts again from here
3 to 5.
to here. From 3 to 5. So bracket 3, I think 5 was an open circle, so that was a parentheses. For our range, gotta make sure we pay attention here. We start at the bottom. So what's our smallest y value that our graph has?
3.
-3. So bracket -3.
Why is that?
Because it's a closed circle. So -3, if I hover my pencil over my graph, I'm touching graph, touching graph. Even though this part stops, I'm still touching graph here. But then I have a gap in my graph. So it goes to the y value of 0. And that's a closed circle, so it'd be a bracket. Don't worry about this part. You won't have a question like this on the test. But here, since we have a gap, we have a break in our domain. And then our graph starts again here at the y value of 5. But it's just a number, like it doesn't go anywhere. So it would just be 5 in the bracket. So don't stress out about the 5 part.
It would just be 5.
It would just be 5 because it's just a constant number. So looking at number 6, we want to graph the piecewise function. So when we're graphing, we always start with the numbers here. So this is where we start. So let's graph one piece at a time. So with our first piece, what number should we plug in first?
-1.
-1. So I'm going to make a little table here just to keep us organized. When I plug in -1, I'm plugging it into my first piece. So I have -1 squared plus 3. Make sure you follow your order of operations. So we have to square the -1 first. We get +1, but then that negative out front makes it negative again. So -1 plus 3 would be what? 2. Because that negative is out front. So the only thing that's being squared is the -1, which makes it positive, but the negative out front turns it negative again. You don't distribute. You can't distribute when you have an exponent. So you have to square it first. So PEMDAS. Got to do the exponent first. So we plugged in -1 and got 2. At this point, do we have an open or closed circle? A closed circle because it's less than or equal to. So I'm going to go to the left to -1 and up 2 and put a closed circle. So that's where we start. We need a couple more points to give us some direction. Since this is x squared, we want to plug in 3 numbers. So what's another number that's less than -1 that we could plug in? Sure, -2. So I have -2 squared plus 3. Be careful, we have to square the -2 first. When we square it, it becomes +4. But then that negative out front turns it into -4. So -4 plus 3 would be what? -1. So I plugged in -2 and got -1. So I'm going to go to the left to -2 and down to -1. Let's plug in one more number. Sure, -3. So we have -3 squared plus 3. We have to square it first, so -3 squared would be 9. The negative out front makes it -9. -9 plus 3? -6. So our point here would be -3, -6. So we're going to go to the left to -3 and down 6. So we always start at the first one. We start at -1. And then we go in the direction of the other points. So that will be our first piece. Let's go to our, because we start at that point -1, -2, and then we go in the direction of the other ones. So our arrow just goes through. So like here's where we started, and then we had that dot next, then that dot. So then we just go that way. All right, let's move on to the middle piece. So what number should we start plugging in here? Awesome. We always want to plug in the numbers that's given. So I'm going to start by plugging in -1. Here it says 2/2. I'm not sure what it's supposed to be. Let's just make it 2/3. So I changed the number because it said 2/2. So I think it's just a typo. I changed it to 2/3. We'll get some practice with fractions. So when we plug in -1, we have 2/3 times -1 minus 2. So this would be -2/3. What do I need when I'm adding with fractions or subtracting? Common denominator. So I'm going to change -2, that -2, to be 2/1. Give us a common denominator of 3. Let's make it 6/3. So that would turn this into -8/3. Now with fractions, it's a little bit harder to see where we're going to graph it. But how many times does 3 go into 8? 2 something. So we just know that it's going to be a little bit bigger than 2. So I'd say -2 point, it goes in, it'd be like -2.6. But really if you graph -2 a little bit more than -2, they're going to look the same. It's pretty much the same thing. So just as long as you know where you're close to. If you know that it's close to -2, that's perfect. Because putting it on the graph -2.1 to like 2.8 is like pretty much the same thing. It's just a point. It almost looks identical. So we plugged in -1 and got -2.6-ish something. So we're going to go to the left to -1, down a little bit more than -2. Is it an open or closed circle there? Open circle. Because it was just a less than. What else should I plug in here? 3. Awesome. We always want to plug in the number that it gives us. So when I plug in 3, I have 2/3 times 3 minus 2. 2/3 times 3, make it 3/1. This would be 6/3, which would be what? 6/3 simplifies to what? 2. And 2 minus 2? 0. Perfect. So we plugged in 3 and got 0. So on my graph, I'm going to go to the right 3 and stay at 0. Open or closed circle here? So because it's the number that it told us, it's an open circle. Perfect. Now here, this one doesn't get an arrow because it has a start and a stop. We started here and we stopped here. So the middle piece, when you have 3 pieces of your graph, doesn't get an arrow. It has a start and a stop. No arrow. Let's do our third piece now. So if it's just x with no exponent, x to the first power, you only need 2 points. So here, plug in 2, because it's just a line. Remember, if it's x squared, you want to plug in at least 3. All right, so for this one, what should we plug in first? Same thing that we've been doing. What did we plug in first for the other ones? 3. So always plug in the number that it gives you first. What's our y? What's the equation here? -4. There's no x here. We're not really plugging anything in. So what do you think our point would be?
3, -4.
Awesome. 3, -4. So x is what we plugged in, but we really didn't plug anything in. The number there is our y. At this point, is it an open or closed circle? Closed circle because it's greater than or equal to. So I'm going to go to my graph, go to the right 3. So at this point, we're going to go to the right 3 and down -4. Put a closed circle there. We need 1 more point. So what's a number bigger than 3 that we could plug in? 4. Perfect. If I plug in 4, what's our y still? -4. It didn't change. It's still the same because we're not really plugging anything in here. So our point would be 4, -4. Now this point's just direction. So I'm going to go to the right 4, down 4, put a point. Start at the first one, go in the direction of the second point. So our line will look like this. When it's just a number, when there's no x and just a number, it's going to be a constant line. It will be a flat line when it's just a number. All right, let's look at the bottom. It says state the domain of the following using interval notation. So for domain, we had 3 rules. If we have a fraction, so let's say I had 1 over x, we'd set whatever's in the denominator not equal to 0 and solve. If we had a square root, we'd set whatever's under the square root greater than or equal to 0 and solve. And then if we had a square root in the denominator, we'd set it just greater than 0 and solve because it can't be equal to if it's in the denominator. If it's not one of these rules, so if it doesn't have a fraction and it doesn't have a square root, then it's all real numbers. So it is going to be all real numbers except if these things happen. How would we write all real numbers in interval notation? Awesome. -infinity to +infinity. Perfect. So for 7, we have a fraction. So we need to set whatever's in the denominator of the fraction not equal to 0. Or equal to. It really doesn't matter because it's just the work that you're doing, but we need to solve here. So we're just solving our denominator. We need to factor. When our leading coefficient's not 1, we could factor by multiplying the first times the last. We get -18. What are 2 factors of -18 that add to 7? Awesome. 9 and -2. So we have x plus 9 and x minus 2. Remember, you could factor by grouping, or if we don't factor by grouping and we do it the shortcut way, you have to remember to divide by the number that you started with multiplying. So divide by 9. So we get x plus 1, and then if it doesn't simplify, you move it in front of the x. So 9x minus 2. So all we had to do is factor the denominator. So then we set them both not equal to 0. x plus 1 does not equal 0. 9x minus 2 does not equal 0. Subtract 1 here, so x does not equal negative 1. Add 2 and divide by 9, so x does not equal 2 over 9. So we factored to find our answer, but we have to write this in interval notation. So we're talking about all real numbers except negative 1 and 2 over 9. So to write it in interval notation, it might help you put it on a number line. Which one's smaller? Negative 1 and then 2 over 9. These are open circles here because they're not included. But we're talking about everything except these numbers. So how would I start? Awesome, negative infinity to negative 1, parentheses. Then how would I talk about the part in between? Negative 1 to 2 over 9. And then? 2 over 9 to infinity, perfect. For this one, yes, always parentheses, because it's not including those numbers. Because x can't equal negative 1, and it can't equal 2 over 9. All right, so this would be our answer. You don't have to graph it on the line, but sometimes it helps to graph it so you can put it in your interval notation. Yeah, like the two numbers that we had here. So it's just, we need to write it in interval notation. X cannot be those numbers. All right, let's do number 8. Let's do number 8. So here we have a square root. To find our domain, we set whatever's under the square root greater than or equal to 0. So we have 6x plus 5 is greater than or equal to 0. How would we solve for x here? Subtract 5, so 6x is greater than or equal to negative 5. Then divide by 6. So x is greater than or equal to negative 5 over 6. We have to write this in interval notation. If it helps you, put it on a number line. If you don't need to put it on a number line, don't.
So how about that negative? It's just invisible?
Yeah, you ignore it. You only care about whatever's under the square root. Everything else you can ignore here. So we're talking about numbers that are greater than negative 5 over 6. So negative 5 over 6 would be here. It's greater than or equal to, so it'd be a closed circle, and we're highlighting this way. So how would I write that in interval notation? Negative 5 over 6 to infinity. And since it's greater than or equal to, it gets a bracket. Let's look at number 10. For number 10, we don't have a fraction. We don't have square roots. So what would our domain be? All real numbers. So it's all real numbers except if you have a fraction or if you have a square root. So here, right, if it's a regular equation with just x's, there's no fraction and no square roots, it's all real numbers. So negative infinity to positive infinity in interval notation. So this one you don't even have to do math. So if it's in a fraction in a square root, we would just say it's greater than 0 and solve whatever's under the square root here. So same thing that we did for number 8. Well, just saying greater than is not equal to, because remember, if it's in the denominator, it can't be equal to 0. So we just say negative 2x plus 5 is greater than 0 and solve just like we did for 8. So for 11 through 14, it says, does the equation define y as a function of x? There's two rules that we have to follow. Y cannot have an even exponent. So it can't be y to the second power, y to the fourth power, y to the sixth power. These would be not a function. Also, y cannot be in an absolute value. This would be not a function. So 2 rules. Y cannot have an even exponent, and y cannot be in an absolute value. So looking at number 12, does y have an even exponent? Is 3 an even number?
No.
No, it's not. Is y in the absolute value?
No.
No. So is this a function? Yes, it's a function. For 14, does y have an even exponent? No. Is y in the absolute value? So is it a function? No.
All we have to put is yes or no.
Put yes or no, but if it's not a function, just show me why. Just, you can say because it's in an absolute value, or just circle it. Just tell me why. So if you say no, tell me why it's not a function. You can either use your words or draw an arrow to it, circle it, whatever. All right. I made 2 questions up, so if you guys want to take a picture of these. Looking at number 15, this is like a question that you guys had on the quiz. So this is 1.8. You will have a question like this on the test. So review your quiz if you need to. What would I do first here?
Subtract 2.
Awesome, subtract 2. The most common mistake that people made here was they would add 2 and 5 together. You can't do that. 5 is being multiplied to the absolute value, so you have to subtract 2 first. So we have 5 times the absolute value of 3x plus 1 is greater than or equal to negative 25. What should we do next?
Divide by 5.
Divide by 5. So the absolute value of 3x plus 1 is greater than or equal to negative 5. What happens here? So remember, if this was a positive number, we'd split it up. We'd split it up into the positive, flip it for the negative. If it was greater, it'd be outside.
Absolute value has a negative.
But our absolute value is a positive number.
So all real solutions.
So if our positive number is greater than a negative, it would be all real solutions. How would we write that in interval notation?
Negative infinity to infinity.
Negative infinity to positive infinity. How would we put that on a number line? The whole thing.
I got that wrong. Wait.
So if your absolute value is greater than a negative, a positive number is always going to be greater than a negative.
I'm so confident.
So it's all real solutions.
Entire sentence saying positive is greater than negative.
I'm going to practice one more just so we can do another. So let's just say I had the absolute value of 2x plus 3 is greater than, we'll say 9. You just throw it away. What would we do here?
Just split them up.
Split them up. So we'd say 2x plus 3 is greater than 9. 2x plus 3 is what?
Less than negative.
Less than negative 9.
That's another question.
Yeah. Yeah, I made this one up just so we could practice solving. You'll have one on the test like this.
And we have to graph it out.
Put it on, this you have to put on a number line, yes. Just like the quiz. So 2x is greater than 9 minus 3 would be 6. Divide by 2. X is greater than 3. Let's do the same thing here. We're going to subtract 3. So 2x is less than negative 12. Divide by 2. X is less than negative 6. So when we put this on a number line, which one's smaller? Negative 6 and 3. Open or close circles? Open circles. Now, before I split it up, it was greater. So greater is in between or outside?
Outside.
Outside. Less than is in between. So greater, we shade outside. And then in interval notation, we'd say negative infinity to negative 6. Union 3 to infinity. So this is just like the quiz. So you'll have a question on the test like this where it'll give you the piecewise function and it'll say like f of 9 or f of 1. And we have to plug it into whatever piece it corresponds to. So f of 9 would belong to which piece? The first, second, or third? So remember, the first one's talking about x values that are less than 2. The one in the middle is talking about x values that are in between negative 2 and 4. And the third one is x values that are greater than 4. So 9 would belong to which piece? The last one. So we'd have negative 3 over 4 times 9 plus 2. So negative 3 over 4 times 9 over 1. Remember, multiply straight across. So that'd give us negative 27 over 4 plus 2. What do we need when we're adding with fractions? Common denominator. So I could make this 4. I'd multiply the top and the bottom by 4. So it'd be 8 over 4. Negative 27 plus 8. Negative 19 over 4. So f of 9 would be negative 19 over 4. So the important part here is just knowing which piece to plug it in, then you just have to do the math. All right, f of 1. 1 belongs to which piece? The middle piece here. 1 is in between negative 2 and 4. So we're plugging it into the middle piece. So 1/2 times 1 plus 6. Would be 1/2 plus 6. What do we need when we're adding with fractions? Common denominator. So I can multiply 6. The top and the bottom gets multiplied by 2. So it'd be 12 over 2. When we add it, we get 13 over 2. Perfect.